years of cloud computing experience, 5 years of Charles River IMS and CRA functional experience with expertise in data loads and data validation, experience in configuration of compliance, user access, layouts, and feeds. 3+ years of experience in using Android SDK, Android emulator, and debugging applications. 3 years of teaching research experience. Publish your associate papers. Sudhir and Michael Hashler project segmentation using public envelopes 2015 IEEE 16th International Conference on Information Reuse and Integration. Fans and Sudhir visualizing association rules in hierarchical groups in 42nd Symposium on the Interface Statistical Machine Learning and Visualization Algorithms. Use Sudhir, Michael Hashler, and Margaret D. Dunham, a new data mining model for hurricane intensity prediction, second IEEE ICDM workshop on knowledge discovery for climate data proceedings of the 2010 IEEE International Conference on Data Mining workshop. Last one, Michael Hashler and Sudhir, visualizing association rules, introduction to the R extension. That's it. Now I request our resource person, Mr. Sudhir, to start his presentation.
Good morning, everyone. Hi, this is Sudhir. Thanks for giving me the opportunity. Mr. Pediraj Garu and Padmanabhan Garu and Prasad Garu and all the respected teachers and students. As you all know, like Prasad has given some introduction regarding me, but I would like to introduce myself too. I have like almost like 13+ years of experience with educational as well as in software. So I'm much more into software, like rather than in the teaching. I do have a teaching experience, but not much as you guys, but I'd like to share something else. So today I will present my, I'm taking this opportunity to share my research, like what have been done over past years, and mostly like to interact with you guys, what you guys are thinking, like what, how you want to take this session forward. Most probably, I'm thinking like to make it as an interactive session, mostly. Actually, my research is little core concepts here, but I don't know how many of you will be understanding, because based on your background and everything, it depends on how you guys will be knowing these things. So I will make it like little short and crisp, like what it needs to be, and I even give some basic background, like how and what it exactly doing, how it will be useful, and in the end we can have some session questions, like how the differences to know, like most probably it would be better if we share like our experiences, like how you guys are doing, like in terms of research or so and so. So let me start the presentation now. I don't know how to present. Cast this meeting. I think someone has already been presenting. I don't know how to present more. Is anyone presenting? Actually, I'm not getting an option to present myself.
Sir, 1 minute, sir. Sir. Okay, Sudhir garu, continue. Sudhir garu, continue.
Hey, I'm sharing. Give me a second. Let me know when you can see my screen, okay? Can you able to see my screen?
No, sir.
Yes, yes, sir.
I'll be in a couple of minutes, like everybody gets its on the screen. So, I request all the participants to mute your audio. I'm hearing some of the background noises. Like, is there any option I can mute or anyone can mute all the participants except me? Okay, good. Okay, let me start on this spatial data mining. Okay, these are my contact details. Like if anyone has any questions regarding anything, not respect to this topic, any other topics or anything, these are my details. Like this is my cell number, this is my email ID. Okay. Okay. In this session, I will be covering some of the topics like introduction, and the other one is my research topic, which I published in this paper. Okay. So what is data mine? How data mining works? What exactly is the data mine? How it has been uh, taken as an interesting topic towards the future, and how it has been evolving over the years. Okay. What exactly the data mining? Data mining exactly stays on top of the data. Like everybody know, I believe like everybody understand like what data is. Data is nothing but it will be in various fields, like whether if it is in chemistry or lab details, like nomenclature details, all those things with respect to chemistry, electronics, like RPM readings or voltage readings. Those all we call that as a data. And even when you guys open any website, any clicks, like you get into the website, suppose you might be having your college website, right? When you have your college website, it will be having an home page where you will click on the links and get into some of the links where you want it. So each link is being routed on each lines, right? So everything will be recorded. That itself is a data. Data is not like it's a traditional kind of data. Data can be of different various forms, like I mean to say structured and unstructured data. Mostly structured means it will have all the columns, like what are the attributes regarding that data, something like that. Unstructured, it won't have any structural format, like so these attributes needs to be there, mandatory or not, something like that. That's like unstructured data mostly is been evolving nowadays rather than structural, but structural is structural. So traditional databases are still evolving, they are also doing their own good. So I would like to know, like everybody understand what the data is, right? Like anything which is related, that is a data. Data is a collection of some attributes. Suppose you can say, how can I say? Okay, there is a company, no, not even a company. There is a organization or an institute like government degree college. So that have the employees database mostly. If they have a database, the all the users like teachers, employees, and students comes under the teachers, sorry, users, where user type will be of different variations, right? In the same way, that is what the data is like, how it has been organized. So once the data is there, the data can be pulled from different other sources, right? Data sources. They can be of different areas like social media, transactional data. Transactional data is nothing but whenever you make some transactions in your bank, right? That itself becomes the transactional data. I hope everybody has their own banks, right? In bank, you do credit, you do debit, right? So you deposit some cash, that becomes the transaction. When you withdraw some cash, that becomes the transaction. So that is called the transactional data. When that kind of data is a structural data, okay? Sometimes if this data has been stored in the form of tables in some database, then that is called a structural data. Okay, if this is not stored in the form of tables, let's say like it stored in some different format. Currently available formats are like JSON, YAML, XML. So all these formats comes under the unstructured format, but itself altogether everything is a data. So anyway, however, that for data mining, data is the crucial part. Like it's a intermediate, immediate initial step, whatever the work we do. So how this one works? Like first, it goes grabs the data from data sources. Okay, data sources can be from data warehouse or however it is. Okay, once it is done, it's the raw data. Okay, it needs to be processed, some collection, some cleaning, some manipulations, transformations. Everything requires something, right? Suppose we have a um, suppose we have an ocean where we will have the um, uh, RFID devices. It will record how much sea level has been raised and decreased based on some calculations, right? So these all RFID devices will transmit the data towards the data source where it does need to be um, recorded. So that kind of data, it will process more number of data, right? We need to know like how clean the data is. Sometimes there might be a possibility, like it might be corrupted or missing data, because suppose we let me explain another thing. Whenever you go to the registration page, right, you will fill only the mandatory fields. Most of the users fill only the mandatory fields. Okay, they leave the optional fields. Okay, when it goes that when you click on that submit, right, this entire structure like uh, will get into the table. Okay, when it gets into the tabular form, your mandatory fields will be viewed as a data, but your optional fields will be viewed as null values, which is nothing but missing values. You client has been asking for you to enter the sum of the data, but you are not want to share some of the data which is not mandatory, so you're not doing that. So at that point, there is a missing data for us. Like who have been using the data, that will be missing data. That kind of data needs to be cleaned up, because to opt and appropriate results, that needs to be cleaned up, right? That is how the process of raw data will be. And next is analysis. Analysis is nothing but suppose think about the universe, like college data. Okay, what we can analyze from the data. We have a database. All students have been registered. Okay, we want to know who have been registered for computer science department, and is there a male or a female? Okay, how many girls have been registered for computer science department for particular course? I mean to say course in the sense like subject or something. Okay, so that kind of information we get it from the data, that either by performing some queries on it or automatic processing. Like suppose college, like government has decided, like college management decided to give some bonus to the teachers and employees, like 5% bonus, so they can run that 5% bonus on whatever who have been applicable based on their experience. Like if 5%, how it has been segregated as 5% for a person who has like 5 plus or more years in the institution, and 2% for the people who are like 2 years. Like there's some rules how we can apply on the data. These kind of analysis we do on the data, which we already been available, right? So next part comes with the data scientist. Data scientist is a person or a methodology where you will publish the insights based on the data. That means we have a data, and you will provide the data. Like suppose a course is there in the university where very minimum number of students has been registering over a couple of years. Okay, why? What are the drawbacks in that one? Why people are not registering for so and so course? Is it not useful, or is it how it has been affecting? So those all things can be reviewed by the data scientist, and he provides the insights to the people who have been using or looking for it. Okay, so after that, he will report the findings. If like the reporting the findings are as many ways of doing it. Some things can be of pictorial representation, some things can be visual representation. All these things depends on how you want to interpret. Most of the users are pretty much like pretty much comfortable with using the charts or results, or visual representation is the most appropriate way for the users how they view their data or the findings. That is how it needs to be. So take an action based on findings. So we find out like so and so course has been not been registered by the students over the couple of years. These are the things that lacks its background or something. So once we find those findings, then people who are responsible for that, they can take actions on that, increase the people who are working on that one, or push the people towards the research, or whatever, however they feel comfortable with, like to make those options and findings. In the same way, if you see this is all overall. This structure has been actually I like this overall framework with data mining, and the source I even published on the slide itself, because whenever we reference something from somebody, it's it's very good thing to acknowledge the work which have been done by them. So that is the reason whenever you like we don't create something new or something uh, great or something like that. So whenever we share the things, whenever we see the things which are good, we appreciate it and we acknowledge them. So that is how I even provided the source there. So if you go to the next circle, okay, that is what it's very high level design, like how this data mining is doing. So what is the business understanding? As I explained about the college and the course on those things, right? Data understanding. Everybody who have been working on this data analysis, they need to be much more aware of on data. Yeah, because domain knowledge is the most expensive thing for everyone, because not many people will have an adverse knowledge of this. I myself don't have like much on data. Mostly, I worked on climatological data, market data, financial data, banking data. So there are many other data sets where people are doing it. So I'm constrained to this because that's the only opportunity I got on to work on those kind of data sets. Right. So that is my domain knowledge. Like if it is on financial, like what are the stocks, securities, how they have been working or going up or down, the market prices based on the market. Currently, market is down, so everybody knows that it's not doing well. So that kind of domain knowledge needs whenever a person is doing some analysis on data. It's pretty much same as other things too. A person who is teaching chemistry for over 12 years is much more into chemistry, right? You can't teach as efficient as an electronics teacher teaching like electronics. So that is how the data understanding means. That means whoever have the domain knowledge, they are best at it. Okay. Most probably, I'm not saying like if they don't have an experience of doing that, they won't be getting it, but mostly on assumption purposes. Okay. And data preparation. As I said, data preparation is nothing but a collection, cleaning, transformations, and so on. Okay, and modeling. Everything needs to be modeled. Whatever the models you build on top of data or anything, everything should be built on models. That is data modeling. How the data models will be. I believe like most of the computer science students which are dealing with the database, or students or teachers who are dealing with databases, they know what the modeling is, right? How you build the model, entity relationship, that kind of model is entirely dependent on data. But when it comes to the data analysis, the modeling will be different. how the modeling will be different based on some machine learning, which I will be dealing, giving you some insight in coming slides. So that is what it is. And evaluation for everything what we run, what we do, everything needs to be evaluated, right? Even in every end of year, teachers will be evaluated. Every semester, students will be evaluated by their exams and those things, right? So based on their evaluation, we will know like at what places we are standing in terms of education or knowledge sharing or something like that, right? In the same way, every model will be evaluated based on some test results, like each depends how the test will be anticipated and attached to it. That depends on how the person is modeling it, right? And deployment is nothing but once the model has been approved and everybody okay with that model, then they will deploy. Like somebody needs to use that one, right? Unless somebody uses it, it's no value of doing those things. So that is what the life cycle of this data is. Okay, going to the next slide, guys. I even like you guys to stop me at some point if you guys have any questions or something. Don't wait till end of the session. Okay, just make it like interactive. And now you have any questions like that thing is not been understandable. This kind of definition is not right, or you can stop me if it is not right or something. Just stop me and let me know, because I also don't know much of the stuff, right? I know I also have the very limited knowledge. So based on my experience and whatever I read, that's what my knowledge is, right? So please do ask questions or stop me if you are not understanding, following what I'm saying. So please make it an interaction, not make it like classrooms teaching, okay? Okay, what is a data mining architecture? How it has been architecture? This is an high-level data mining architecture. Okay, this is not the only way of architecture. Okay, this is somehow I feel like this is what it needs to be. Okay, it might not be right. Some might add some more blocks. Some might add some more layers. It depends based on how they want to do that. Most probably from my side, like whatever the data is coming from, different databases, data warehouse, web, and other repositories. Okay. On top of it, I place the data cleansing, data selection, and data integration. What is data cleansing? Data cleansing is nothing but I explained like there will be some missing data, right? In the data, whenever you see it depends. Like not everything will be recorded, right? So that is what like data cleansing. If most of the, if suppose we have like 10 columns, okay, in a data, like everybody knows, right? Database means database is a set of tables and procedures, functions, and what else? Like views and everything comes in the database. Okay, everything resides of the database, right? So tables. Let's comes to the tables. Okay, every table is a data set for me. Okay, as I mentioned, like there will be a missing value. If a column, suppose I have 10 columns in a table, okay, 10 columns and 100 rows. 100 rows means, you know, right, 100 transactions. In a banking way, if you see, like you made like 50 deposits and 50 withdrawals, then you will become like 100 transactions, right? That 100 rows isn't what I'm saying like as a row. If that is the case, if one of the column has 90% of data missing, okay, we don't know like if a 90% of data is missing means 90 rows have a null value on that. Only 10% is there. So in my aspect, like based on my knowledge and everything, I don't consider that column at all, because that doesn't make any sense to me in terms of giving some insights to the people who have been looking for that kind of data, right? So in the process, data cleansing, either I fill the nulls with some data, like I take the average of those 10% and put it in everything, or it depends, like however you want to handle that situation, because there are a number of methodologies based on each domain. So it's not an appropriate, like everything will not have an appropriate solution for that one, right? So that is what the data cleansing is. Data selection, as I said, in 10 columns, one of the column has 90% of data missing. I don't need that column at all. So my analysis will be based on only on those 9 attributes. I mean, it's a 9 columns. I remove that 10th column. I don't need that. So that's one area, one level. In that layer, we can cover that one also. And data integration. Data integration is nothing but we can pull this data from different sources. As I mentioned, database, data warehouse, so and so, so and so, right? So once it goes to the upper layer, again we build a data warehouse there because we are getting the data from different sources. So we need to consolidate everything into a single data warehouse where we can run our computations for transformations or so and so. Okay, and on top of it, I will be placing a data mining engine. Data mining engine is nothing but for now, till this slide, because I will explain what the data mining techniques are going forward. So data mining engine, for now, think that as a layer which will do the data mining. Okay, some kind of analysis. Okay, once it is done, it goes to the pattern evaluation. Once pattern has been identified and everything is done and results have been interpreted, it goes to the user interface. User interface is nothing but a client view. Like, suppose you all are the users and using the so and so tool to know the results, right? So that is what the user interface is. And again, user will give the feedback. Pattern evaluation is so and so is not that good, that great. It needs to be modified or realigned with some other things. Then it goes to again to database engine, data mining engine. Again, it evaluates and do some like what do you call it? Reprocessing or so and so and remodeling again, and then again goes back to the user interface. That's an circular view. That is nothing but getting the feedback and aligning our model based on that. It's nothing different actually. In our day-to-day life, we do the same thing, right? Every teacher or lecturer will have the review sessions with the students, how they have been performing, getting the feedback from students, how they are teaching. They can improve there or they can go slow. How we evaluate ourselves, right? In the same way, model and pattern will also evaluate itself. All these processes will become automatic when it goes to the machine learning. Suppose everybody might have seen the movies, right? In the movies, we have robots like where they can perform some of the actions like lifting a spoon or lifting so and so, right? Lifting some fork, like these kind of things. It's automatic doing things. Like machine learning comes into the picture. If they go beyond the machine learning, then artificial intelligence comes into the picture. Like based on this machine learning results and these things, artificial intelligence will be built on back of the process and it will give its insights. That means like artificial intelligence is nothing but non-human interaction, how doing the things automatically. Okay, so this is what the basic data mining architecture. As I said before, there might be a number of ways of representing this one. So this is my way of doing it. Okay, what is data mining techniques? What comes under data mining techniques? Data mining techniques can be classification, clustering, regression, outer. Sorry, that is not outer. It's actually an outlier detection. Okay, and sequential patterns, prediction, associations. These are the 7 main techniques that have been classified till now in data mining. Okay, there might be few more coming in for in future because whoever experiment the things and comes up with new techniques, then they will add something to that data mining. That is how these have been evolved, right? Initially, it started as analysis, classification. Somebody liked clustering, like more analysis based on the clustering. So these all are categorizations in terms of techniques. Okay. Okay, classification. There is a text there. You guys can read out there, but I will give you different examples so you can understand more. Okay, classification. In a In a class, how do you classify? What is a classification? It's a distinct between the groups. Okay, classification. Okay, in a college we have different departments, right? So our college has been classified into number of departments. That is what the classification. That means whenever the students are there, right? The students belongs to certain department. So it's a clear distinction between where and how they fall in different groups. That is what the classification is. Based on that definition, you guys can read that one out, and it's like general definition and some example over there. But to better understand, I'm giving a different examples, real-time examples, so you can easily identify yourself. And clustering. In the same way, clustering is nothing but a group of objects who have been doing the same objects. Like in a class, everybody will suppose if a class has a grades of A, B, C, D, the students who have performed well will fall on A, right? That's an obvious thing. And who have not been performing well, they go to the D, right? That is what the clustering is. That means we analyze a group of objects. Okay, and this can be of many other ways, like density is there, like how we identify what kind of clustering we are doing. It depends on however the person chooses that underlying thing, right? I'm not going in deep of those things because each technique will take like more number of days to cover the topics because they are huge history related to that work, right? So I'm just giving the basic examples and definitions. Okay, regression. Everybody knows regression, right? We are all math students. We know what regression is, right? Regression is nothing but we suppose we do something, and we think like these variables needs to be adjusted based on the slope and intercept, and we go back again, we change those parameters, and again we evaluate the expression. That is what the regression. Regression can be of different ways, like linear regression, which has only line and slope, sorry, slope and intercept. And there might be other things like logistic regression, many other regressions. Like you can have your own regression if you have the mathematical formula which will follow those things. You can have that one. You can have polynomial, binomial, how many you want. Okay, that is what the regression is. Outlier detection. Outlier detection. What is an outlier detection? Suppose a group is there, highly performing group, which I said like people who have got A is in that group. Okay, and B, the people who have got like less marks or something. Okay, C and D. We all together have four grade groups, right, in the class. So if a person is not following any of the four groups, then he is called an outlier because he don't belong to any of them. Suppose a person perform very well other than grade A grade, so he falls on top other than A group, right? So sometimes that is the case. So that is how the outlier detection is. Suppose a person is not falling in any of the groups, or suppose in a group, suppose we have 30 students, right? In 30 students, 29 are around same marks, but 30th person is on very top. Okay, because of him, the object group size has been identified and defined. So if we remove that, all the students will fall in the same. Like the distance between, like distance means the difference in their marks will be very minimal if we remove that person. So that is what the outlier detection. That is also happens automatically. So tracking patterns is nothing but sequential patterns. Like I wake up, I do shower, take shower, and go to college, go to office, come back home at certain time after office. This is all the sequential patterns. Okay, these all things. How we identify them? Suppose a product is there, right? In the same example, sales of a certain product seems to be spiked just before the holidays, or notice a warm weather drives more people to you. Okay, when suppose we have like festival seasons, right? At that festival seasons, shopping will be more at spike. So at that point, that is like more, right? That is not actually happening. That's kind of a pattern. Every holiday season or festival season, people will tend more at the buying. Nowadays, it's been lockdown, so all things are going on. But usually, that is the what, like identifying the spikes. That becomes a pattern. Whenever that becomes a pattern, we track those patterns. That way, we can give more insights to that. I will give you one example. Like in festival season, if a person is having a clothing store that is nothing but a shopping mall or something, he can reduce the price, or he can make some adjustments to make more sales at that time and bring more profit to his organization or institution. So identifying these patterns, they can adjust their business. That is what the sequential patterns or tracking patterns. Okay, prediction. Prediction is nothing but we analyze something based on the history data and we predict something. Actually, I worked with hurricane data. I even thought of one of the paper presentation publication. What I did is in that one, I took the historical data of 35 years of hurricane data and predicted over 6 hours how it will be performed. Hurricane is nothing but it's kind of a cyclone. Okay, cyclone will be of below 20 knots in pressure, like how the wind movement is there, right? Below 20 knots, it will be a cyclone. Okay? It will travel and hit some ground or a ocean. It fall into the ocean, right? That is what the cyclone is. In the same way, hurricane is a different thing. If the velocity of the pressure of air, wind becomes like 34 knots, then it becomes an uh, hurricane. It will have a flexibility, not flexibility, sorry to say that, but it will even lift the houses. Like there are some videos you can check in the YouTube or somewhere, like how hurricane that. So if we can predict that, we can evacuate the people who have been traveling in that path. Okay, everything will flow in the path. Okay, whenever it's moving in a circular direction, it will have some tracks, right? In the same way, like when a cyclone comes, it comes to this area and again it goes to this area, it goes to that area. In the same way, how it is traveling, even we can track that one with the hurricane in the same fashion, right? So whenever we have something like this, if we can predict like by this time this hurricane reaches to this area, by the time to reduce the uh, bad happenings on around the place, we can evacuate the people. We can reduce the people's life like from getting suffered. So those things can be done at an eye level. That is what the prediction is. That means over 6 years, how it has been performing, at what level it will be landing, or at what level it will be falling on the ocean. Okay, those things will come under predictions. Predictions mostly based on the historical data, how it has been done. Association rules. Association rules is nothing but what can I say? Okay, there is a store, okay, grocery store, where a person buys a bread, butter, okay, and the next person buys butter and some sauce, okay. So suppose there are 100 customers who buys bread and butter at the same time, and there are 20 customers who buys bread and sauce at the same time. So the correlation between bread and butter, bread and sauce, it depends on number of transactions. 100 and 20. So total transactions are 120. In that, the more confidence and support goes to the bread and butter. So whenever you do online shopping, right, they will recommend that when you buy bread, they will automatically recommend that butter to you because it has an 80% of confidence and support for with that correlation. This plays a major role in the recommender systems. I hope like most of the people will have, like most of you guys have like Amazon or so and so online trading e-commerce site, right? They recommend something to you. Even if you guys open your Facebook, they recommend the videos or something based on your clicks and history. Even if you open YouTube with your account or something, they will keep track what you're viewing, what kind of videos you're seeing. Like based on that, they recommend the other videos. These everything, these recommender systems are all of them been working based on the association rules. Okay, this is what the techniques. And I think I'm taking more time. So what I will do, I will skip some of the topics like basics. Actually, I only want to concentrate on basic terms because to understand the research, what I'm doing, it needs a very basic understanding of definitions and everything. Okay, this is what till now we saw, like what is data mining, what are the data mining techniques, how it has been architecture and so on things. How it comes to the spatial data mining. What is spatial data mining? When a data set has been aligned with three parameters, then we say that as an spatial data. What are the three parameters? Latitude, longitude, and altitude. Everybody know, like everybody is using Google Maps or something. Everything, like whenever you search for, like want to go to some destination, you know, it's like what is latitude? Nobody knows what is latitude and longitude because we usually go by its name, right? Route name. So whenever a data set is been aligned with the latitude, longitude, and altitude, then that becomes a spatial data. Okay, so in the same way as I explained about the hurricane data is unstructured data. That is what we perform some processing. It's more of an horizontal kind of data. So we made it like vertical data to have some different results on that one. So this data has a lat and longitude because this hurricane track has been moving around some places, right? Each place will have its own landmark, that is lat and long points. Okay, so that is what the data spatial data mining. I will skip some of the topics here. Most probably, I'm skipping ETL. ETL is nothing but transform loading. It's a kind of system where the data can be pulled from different sources and put it to the data warehouse. Okay, that's kind of a data loading kind of thing. And whatever, everything is understandable here, like with the names or so and so. Okay, this is my research. It is nothing but a novel approach for partitioning the trajectories using expanding bounding rectangle. Nobody knows, right? Like what is partitioning the trajectories? What is a trajectory exactly? Nobody. Going forward, I would explain what is expanding bounding rectangle, why it has been there, so and so. And my advisor is Dr. Michael Aslan. I've been working with him on this research. So yeah. So whenever you pick an article or a conference paper or a journal paper, you need to be read in a different way. It's not like going from A to Z, like 1, 2, 3, 4, 5, 6 pages or something. It's not like that. Like you need to be little smart how to read the articles or knowledge papers, right? Every knowledge paper should start with an abstract. Okay, in the abstract, you will know like what this paper is. Okay, after reading the abstract, after getting an experience on that knowledge on that abstract, go to the conclusion. Every article or journal or anything ends with a conclusion. In the conclusion, you will know like how it's been tested and what kind of methodologies have been used and what he achieved and what is his future. Once you read top and last sections, you will know what kind of paper is done. In between, everything is like movie script. Like you will explain like how the story starts, how it ends, and what kind of main episodes will be there, and that is how the any paper can be related to a movie, right? Because all of us loves movies, right? Yes, nobody's talking anything, and nobody's stopping to. Okay, this is what I mean to say in the abstract. Okay, let me explain. Like instead of going in deep about this topic, what it really does. Okay, we have like every country will have a border, right? Every country will have its borders, right? Sometimes when a countries overlap, like or mean to say shares the land. Suppose India, Tibet, I think, yeah, Tibet or Nepal, those things, right? Bangladesh. Most of the things, most of the areas, they might be a truck transportation. Okay, truck transportation is nothing but ground transportation. Means trucks come to this country and go to the other country, right? They move the goods. Suppose a truck is there, it has been GPS equipped with the GPS. Okay, it enters the country. Okay, it enters the country and it moves around. It has some source and destination. Suppose it enters at Nepal and goes to Tamil Nadu. Okay, it needs to take some path along the route, right? There might be like there will be any number of trucks standing in the borders to cross over, right? To get the ground transportation or whatever it is. Like mostly truck companies comes with motor vehicles or some clothing previously. Nowadays, people are moving with the ships if they want to go by on sea route or something, right? So okay. If that is the case, trucks needs to move to cross the borders and move to some place or some areas, right? At that point, the how much the border security can check, right? They can suppose 5% of checking might have done. They won't open anything. They won't see the stuff because to see the stuff and do the things it takes like longer time, and the wait time will be more. So they will only check or inspect only the suspected trucks, right? So there might be a possibility a truck has been cleared its clearance from the border, but it is carrying a legitimate goods. Legitimate goods means I can say some different, like the goods which needs to be, which shouldn't be accessible to the public. Okay, those kind of goods. Okay, it enters the borders, goes to Bengal, and it takes some route, right? Yeah, it takes like 3 or 4 stops in between to reach to the destination, Tamil Nadu. So at that point, in the same way, if the truck has been deviated the route and they dumped or unloaded the stuff which is not been legitimate to the public, okay, we don't know what that stuff is, what that kind of things is. Suppose if we to tackle that problem, if we can equip that device truck with the GPS, okay, I know there will be some manipulations can be done with the GPS too, but crossing all those things and having an equipped GPS to a truck, we can track the location where it has been waited for so long, where it has been moved, how it has been moved. Suppose and every destination might obviously have because trucks, huge trucks won't travel uh, along the village routes or something, right? It needs to be on a highway. So most probably highway routes are like 3 or 4 max. So 3 or 4 routes, right? Suppose a person has been deviated from the path. We say that has been outlier. Okay, that means the person is doing some illegal work or something is doing that. Those kind of things can be identified by the machine learning or data mining. Okay, this entire route we call that as a trajectory. Okay, a trajectory, a moving object or a moving through space. Okay, trajectory data is a moving object or continuously moving. location is recorded, and that recorded data can be called as a trajectory data. That is what that analysis is. What we get from that one, we can monitor or predict the moving object for future position. By analyzing previous data, we can even extract the outliers from the regular moving objects. Okay, suppose there are 100 trucks which are going in normal route and they are performing well, they are good, but one of the truck has been deviated and it's doing some different things. By that means that is not going along the route, so that is an outlier. So we call, like, we can intimate cops or something, like regular authority people who can take action on them. Those kind of details or results we can draw from this analysis. As I explained, like spatial data mining, you guys can go over this, and this can be easily understandable and read. And this is some of the history work, like what kind of how, see, the trajectory is a long road, right? We can't analyze the whole trajectory at a time. So what we will do, we'll slice the trajectory, we make small parts and read some, right? This one will give you the better idea. Okay, the set of trajectories. Each line is a trajectory, and points is along that line is a partitions. Okay, if you take smaller partitions, you will know like which and how it is been. If you look at this one, right? It is crossing one of the line and again crossing another line, right? So this is a kind of outlier. This is not an actual path. So that is what that outlier detection. That is how we relate the things and how we map and detect the outliers. Okay, this is one of the previous person who did J. Gilly and Jibai Khan. Those are the persons who did this initial methodology, how to partition the trajectories and how to detect the outliers. In the same way, I am also proposing something else on the same lines, but in a different and efficient way. That is why I'm saying different and efficient way, because I got the results which are good compared to the previous approach. Okay, what is my approach? What is a bounding rectangle? Suppose this is one in A, this is one GPS point. Suppose I am standing here, I take this one and I move to the next point, and that will be in B. I expanded the rectangle and put it in one bound. The bounding rectangle is nothing but a grouping. But how I'm grouping? It is based on fixed A length and expanding B length. If you see that from my picture. And this can be any direction. It's not need to be east or west, north, or any direction. It can expand on any direction, but it needs to start with one point, one data point. Okay, this is an arcade track. This is data from NOAA, which is an climatological society in US. So it tracks from El Paso to Houston. Okay, this is the partitioned. You see the blue dots and red dots, right? Red dots are the noise which I included. Like every GPS won't have the actual one, right? It goes by the triangulation method to get the point. So once, if you stand here, if you step aside for 2 feet, it will give you a new reading. That is not exactly a one, but 99% of accurate location readings it will have. But to impose that 1% of noise also, so that is the reason I included that in my partitions, like simulated track. So red one is the method used by the previous person, black one is by me. So that is what the tracks, how it has been partitioned. Okay, two algorithms. One is mine and one is previous MDL. If you see, my approach is A, B is partition and detect algorithm, and it has some mean square error, root mean square error. Based on that, I am performing well, I feel. because 0.97 is better than 1.17. 1.85 is better than 2.66, right? So that is how I saying like it's beneficial, right? And every project or everything, every model will have its limitation. I do have some limitations, and that approach also has some limitations. Some of them are like processor, those things, and something like I am not. I'm only considering two dimension because lat and long only because that is always moving on the land, right? We can include this to a third dimension, which takes the consideration of altitude, which we can track the hurricane kind of thing. Because hurricane also, but track movement, I'm only taking the lat and long. I'm not taking the altitude. With the altitude, then the frequency might change. The frequency means to say a velocity, how it reaches to the land, those things. And this is what like conclusion, which is nothing but I did something. This is what how it is performing. It is performing well compared to the previous uh, methodologies. So this is performing well. This is good approach. That is what I published, right? In the conclusion, that is what I this conclusion is. So almost done. So I will open up for the questions or anything if you guys want any questions or like to know how the things comes to the research, and I do have some questions. Sham, you have some questions?
Hello.
Sham, you have some questions? Go
Hello.
ahead, guys. I'm listening.
Yeah. Do you hear me? This is Rakesh.
Hi, Rakesh.
Yeah. Thanks for sharing the knowledge on data mining. This is the first time I have heard on this topic. So, a few questions in my mind.
Sure.
Please, could you please clear me on this?
Mhm.
As you said that we have a few databases. I mean, which kind of database we'll use on this data mining? I mean, we have different kind of databases like Oracle, MySQL, MySQL, and others. So, and I'll be working on it, and as well integrated tools. So, could you please clear on this,
It can be any database, Rakesh.
right?
Uh,
Oracle.
any database.
Yeah.
It's not like database is nothing but a storage of data, right?
Yes. Yes.
Storage of data is not an option for data mining.
Yes.
Any kind
I
of
mean,
data.
what exactly? What exactly tool? I mean, which related to? I mean, for consistency and others.
mm, I say current technologies are going for cloud. If it is
Okay.
AWS, Redshift,
Yeah.
if it is something else, Snowflake, if it is Azure, some other
Azure.
concept,
Yeah. Yes. Yes.
it gives an additional computational efficiency.
Okay.
Yeah. Traditional databases you can use it, but underlying on top of it, you should even know how computational load you will be putting on the DB.
Yes. And one more question. Can I ask or not? I just on behalf of everyone. How do you have the career opportunities on data mining in future?
In future,
As I mean, as freshers are eligible or not, or else how much experience do we need to acquire a job over data mining?
nice question. Uh, See, every career opportunity will ends up with revenue, right? So if it is getting more money, we go there, right?
Yeah.
So everybody who has knowledge and want to pursue some things, they can go for it. It
Okay.
really takes like a couple of years to get into it because you need to really understand like what the concepts are because without hands-on you won't be getting there, right?
Right.
So
Right.
to get an hands-on you better need to uh, do some labs or experiments, get
Yes.
the data. You don't need heavy expenditure to spend on that one. Get the data. Yeah, already it's been available. What kind of data, you need to understand the concepts of underlying concepts like
Yeah.
machine machine learning, which leads to the artificial intelligence. So machine learning and data mining travel side by side. So
Mm.
yeah.
And for the, yeah, please carry on. Sorry.
No, 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 go ahead.
Yeah.
And
Is initial level, can we use this subject data analysis algorithm for this data mining?
it depends, like what
Right.
kind of
Yeah.
data analysis algorithms you will be using. I
Uh,
would say for this course, the
mm,
basic needs to be algorithms,
yeah.
how you'll be using, and you need to know the big O notation for this algorithms because performance takes the preceding. And other one, I will say techniques, how you will be using, and you need to have a domain knowledge of what data you will be considering.
Okay.
So I feel like these three will play a major role when you opt something for that.
Okay. How, and the same question again, how are the career opportunities in over the globe regarding to, I mean, related to this data mining?
Okay, over the globe, it depends, right?
Yeah.
India, China,
Yes.
Asian countries are like service sector. Okay,
Okay.
they provide a lot of support services, those kind of things. So
Right.
if we can enhance with the research areas also, that gives a better opportunities. Like because USA, UK, Europe, they will spend a lot of money towards the research, towards the new technologies. So the people will be more of an architectural level, right?
Okay.
They are the service oriented. Okay. Whenever the
Right.
service comes, they give it to the third party. Mostly India is built up as a service oriented, right? That's where we are lacking it. But it depends how and what you pay.
Okay. Fine. Thanks for clarifying. Yeah. Please go ahead. Thanks all.
No. Any other questions?
Because of convising.
I can't hear.
Sir, any more questions?
If nobody has any question, I do have questions for the teachers.
Okay, sir, go ahead.
Like uh, government degree college. Actually, 30 years back, my father studied in the same college. So, how you are impacting the students towards the research? Oh, is question clear? I'm just asking how you are pushing students towards the research. Okay. Okay.
Okay, Sudhir garu. Thank you, Sudhir garu, for giving a wonderful lecture. Thank you, participants. Now I request G. Bhaskar Rao garu, HOD, Department of English, to propose the vote of thanks.
Thank you, sir. Prasad, sir. Thank you very much. I take this opportunity to propose the vote of thanks for this absolutely illuminating webinar session that has been taken place today by the Department of Computer Science, Government Degree College, Rajol. In this connection, I would like to express a deep sense of gratitude to the Honorable Commissioner of Collegiate Education, Amravati, Andhra Pradesh, for his consistent encouragement and support in conducting the programs like this over a period of time. Thank you very, very much, sir. Then I must thank Honorable Regional Joint Director, Rajahmundry, Sri R. David Kumar Garu, for his remarkable cooperation and marvelous inputs whenever necessary. I think without you, such programs can't take their practical shape, sir. Thank you very, very much, sir. After that, my thanks are due to Honorable Principal, Government Degree College, Rajol, Dr. K. Pidraj Garu, the anchorman of the entire webinar, whose wish and dream to conduct more and more webinars from this college. And we are delighted with your constant involvement. Your support is never belittled, sir. Thank you very, very much, sir. I also thank in this connection Honorable Vice Principal Garu of GDC Rajol, Sri TSV Padmanabhan Garu, for his constant encouragement and support in this regard. Nextly, I would like to express the profound gratitude to the prolific resource person of today's webinar, Mr. Sudhir Chilluboyna, for his astounding lecture on spatial data mining. Thank you so very much, sir, for attending this webinar at this odd hour, because everybody knows that you are attending this session right away from America, and it is almost 2:30 early in the morning to you, sir. And even at these early hours, you are with us, and despite this, you are with us today. We expect many more programs like this in the days to come from you, sir. Thank you very, very much, sir, that this session has been so wonderful that you have illuminated our participant and student participants, faculty members, and all others with your gracious presence. Thank you so very much, sir. I must not forget to thank Sri K.S.N. Prasad Garu, lecturer in computer science, Government Degree College, Rajol, whose tireless endeavors have made this webinar a reality today. Not only this webinar, for the last few days, he has been the anchor person in conducting webinars like this. Thank you so very much, sir. Further, I cannot restrict thanking the technical pillars of this institution, Dr. P.P. Bose Garu, lecturer in commerce, Sri K. Gopiram Garu, lecturer in computer applications, for their magnificent contribution in terms of technical excellence of this webinar. Thank you so very much, sir. Without you, we can't imagine this webinar to happen today. And I also thank the participants from across the world whose overwhelming response has made the program a successful one today. Last but not the least, I thank all the teaching and non-teaching staff of Government Degree College, Rajol, for their priceless contribution in participating in this webinar and making it a successful one. Thank you, sirs. Thank you very, very much for this webinar to happen. Thank you all.
Thanks for the opportunity, and anything like you guys have my details. If anybody interested in any of the research topics or anything they needs to know, they can contact me anytime. But give me like a couple of hours or a couple of days to respond. But I will definitely give a response to that one. And don't worry about the timings about here, because I usually go by sleep by 9 a.m., 9 p.m. in the night and wake up around